welcome. So in this lecture, I'm going to do another one of these examples of integration by parts. This is going to be a definite integral. And it's going to include kind of a special trick, but it's really neat because this is actually the trick you use. You might wonder how you're going to integrate the natural log of x, which is a very important function. And you actually do it by integration by parts. So I think this is definitely something that people should see. And so we're going to do this. And this one's in some sense a little bit usual or tricky. So what we're going to do is this here is actually going to be our u. That's not true. Yes, it is. Okay. And this here is actually going to be our dv. So that might seem a little bit strange, but something that might give you an indication that that might work is the fact that the derivative of the natural log of x, if we take it, we actually get 1 over x, which is going to be a much easier thing to deal with, particularly if we're picking up from over here a copy of x. Okay, so let's just kind of work through this. So we have u equals a natural log of x, which gives me that du equals, so I take the derivative of this, so I get 1 over x dx. And then for my dv is going to equal dx, then that's going to give me that my v is going to equal x. So you can see that these are much easier functions to deal with, and then we're just going to kind of continue on. So this is going to equal. Remember that we keep our bounds here, so we have the integral for, okay, well, I'll write it this way. So we have this, I'm just going to repeat this again. So this here is going to equal, so we need uv. So we have, oops. So I'm going to have ln of x, so that's my u, and then I need my v, so that's x. And this is, you know, there's no integration here, so it's okay that we have the natural log, and that's the only place that's going to show up there. And then we can't forget our bounds, so we need to go from 1 to e. So we keep those in there. And then I'm going to go minus the integral of, and then I need v du. And you can tell this is looking really good, right? So I'm going to get x times 1 over x dx. And I make sure not to forget my bounds here. Okay, my bounds just kind of propagated through like this. Okay, and now this is very nice. This cancels, so we're going to go ahead and do that. So this is going to equal, and I'm just going to swap the order of these just to make them nicer there. So natural log of x from 1 to e. And then these are actually going to cancel. That's very nice. So I'm just going to get the integral from 1 to e dx, or 1 times dx, if that confuses you. Now, I can just integrate this. That's not a problem. So I'm going to get the integral x ln of x from 1 to e. And then over here I get minus. And so this is just going to pick up the x from 1 to e. Okay, so I can now just do each of these separately. So I did, you know how I like to do these? I like to put my parentheses here, like that. And then the natural log, I put my parentheses. And then minus, so then we have the same thing like this. Okay, and then I put my e and my 1 in, so I put my e here, my e here, my 1 here, my 1 here. And then now I need to do this part here. So I go ahead and do that. So I go minus. And then I'm going to put big parentheses. And then I'm going to go. So I'm going to go for this one. And this is going to be like this minus this. Again, we do upper and then lower. So we go e and then 1. Okay. And now we can just kind of, well, we can write here. So the natural log of e is just, let's just kind of write a few things on here. So this is going to be 1. The natural log of 1 is 0. Right? And over here, I'm going to distribute that out. So let's now kind of continue on. So this whole term becomes 0. So I'm going to get that this is going to equal, and I'm going to get e, and then I've got minus 0. So that one's not bad at all. And then over here, we can just go ahead and distribute. So I have minus e plus 1. So I'm just going to get left with 1, which is what I got the last time I did it too. So that's always a good sign. Okay. So what did we do? So this is just this really nice trick because, as I said, I feel like this is very worth seeing once in your life. This is how you actually integrate the natural log. And so we're going to take, what we do is we make the natural log our u and the dx our dv. The derivative of the natural log is 1 over x. So we take that times dx to get our du. And then to get our dv, so we have to take, so you can imagine a little 1 here. We take the antiderivative of that 1 and we get x. And then this is just our uv minus the integral of v du. And we remember that we have bounds on each of these. I just canceled these out to write that again. I also just kind of swapped the order. We can do that. That's not a problem. Multiplication is commutative. And so now we can just plug in our bounds. We try to do this very carefully. By, using our parentheses very carefully so we don't miss any minuses and so on. I usually write it with parentheses replacing the x everywhere, minus with parentheses replacing the x everywhere. We put the upper bound in first, then the lower bound. We do the same thing here. The upper bound goes in, and then the lower bound. And then I just kind of wrote this out. We do need that the natural log of e is 1, and the natural log of 1 is 0. As I've told students before, this might get a little bit difficult sometimes to remember these values. And so students always, oh, I don't understand the natural log. I get a lot of students who come in and tell me that. And the reality is I don't really understand it either. I just know its relationship, right? That the natural log of x equals y is the same thing as having that e to the y equals x. Okay? So if I was trying to figure out the natural log of e, so I'd say, okay, the natural log of e equals y, and then I just kind of, okay, that's the same thing as having that e to the y equals e. Well, what does y have to be? What does y have to be in order for e to the y to equal e? It has to be 1. Okay, so that gives me that y has to equal 1. That's the only way for this to work out, is for y to equal 1. And then I do the same thing, right? If I'm trying to figure it out for 1, so I take the natural log of 1 equals y. This translates over to e to the y equals 1. Well, how do you get that? That has to be 0, okay? So this tells me that y has to equal 0, okay? Great. So don't get scared by the natural log. It's just the same thing as the exponential, it's understanding it. It's just understanding the exponential function. And that one I feel like is somehow a little easier for us to understand. Okay, great. So I hope this makes some sense. It's cool, exciting. You actually learned how to integrate the natural log. And I will see you for one more of these kind of examples of integration by parts in the next lecture.